Chapter 1, Linear Functions. Find an equation for a linear function containing the points -2, -3, and 2, 5. So this is a review of pre-calculus. We want to label the points x1, y1, x2, y2, and compute the slope. The slope is going to be y2 minus y1 over x2 minus x1. So it'll be 5 minus the -3 over 2 minus the -2. Double negative is positive, so this is 5 plus 3 over 2 plus 2. 8 over 4. 8 divided by 4 is 2. So slope is 2. And just a comment, a key part of first semester calculus involves computing slopes of curves that are not necessarily straight lines. The slope of each point on the curve is equal to the slope of the tangent line at that point. So there's a diagram here. And in word problems, the slopes represent velocities or rates of change. But we'll be using the formula for the slope of straight lines to compute the slopes of curves. So this is an important part of calculus. Once we have the slope, then we can use the point slope form to write down the equation. The point slope form is y minus y1 equal m times the quantity x minus x1. It doesn't really matter which point you use as x1, y1. I'll use the point -2, -3. That was the first point that was listed here, -2, -3. And plugging in the numbers, we'll have y minus the -3 is equal to 2 times the quantity x minus the -2. So 2 is our slope, and the point is -2, -3. That's why it's called the point slope form. We could simplify this to get the slope-intercept form. So double negative is positive, so this becomes y plus 3 is equal to parentheses x plus 2. And we can distribute the 2. So we'll have y plus 3 equals 2x plus 4. And then subtract 3 from both sides. And that will give us y equals 2x plus 1. So that's the slope-intercept form. The slope-intercept form is actually unique to that equation. The point slope form can vary. You can use. You don't have to use x1, y1. You could use x2, y2, or some other point, as long as the point is on the line. And oftentimes in this course, it's going to be useful to express this equation as a function. If you have y by itself, y equals, and then some expression involving x, then y is going to be a function of x. And the notation, if we want to emphasize that y is a function of x, we use f parentheses x. And you read that as f of x. In this context, it does not necessarily mean multiplication. It's just a way of emphasizing that y is a function of x. So we write f of x equal to x plus 1. And that concludes this presentation.